Hello, everyone. Welcome to the 7th SPM User Meeting hosted here at McGill University. Thank you for joining those both virtually and here. Today, I'm going to just quickly do an introduction to Zurich Instruments for scanning probe microscopy. My name is Jorge Medina. I'm one of the scientists with Zurich Instruments based in the US. So just some quick housekeeping. Due to online attendance, we do need to be cautious of the time. This chairman will go ahead and stand 5 minutes before the end of each talk, and then we're going to allow some questions at the end. We're going to come to you if you have a question so that the online attendees can hear the question that you ask with a microphone. Everything's going to be recorded should you want to go back and look at it in the future. At the end of the session, right before the coffee break, if we could all come down to the front and we'll take a group picture. And then remember, at the end of this morning's session, we're going to go ahead and walk to a venue that's here on the map, and we're going to have lunch. And it is at the Thomas House. So a quick introduction to Zurich Instruments. We were founded in 2008. We have over 170 people around the world. We have footprints in 25 nations. We're still headquartered in Zurich, Switzerland. We have some large offices in China, US, Germany, Korea, Japan, France, India. And we were recently became part of the Roden Shores family in 2021. And our motto is we're a company of scientists for scientists. So Zurich Instruments' mission is to provide best-in-class signal measurement instruments for advanced R&D labs. So what does that mean? So basically what we do is we mix high-performance hardware with our own software that's designed to make your experimental life easier. And then we have our instruments that are able to do quantum control. We do lock-in amplifiers, boxcar averagers, and impedance analyzers. So some tools that might be useful for you guys in scanning probe microscopy are, for example, our instruments can have a phase lock loop. You can do multiple frequencies in one scan. You can do resonance tracking and a few other things. Some example applications are, say, EFM or electron force microscopy, Kelvin probe force microscopy, and time-resolved SPM. And because we have tools like the data acquisition, integrating our device into your setup, whether it's home-built or commercial, is pretty easy. So our lock-in amplifier workhorse for scanning probe microscopy is the mid-frequency lock-in amplifier, which we call the MFLI, and it can do all dynamic mode AFM. It can go from DC to 5 megahertz. It essentially adapts to all SPM platforms, whether it's home built or it's a commercial system that you can plug into and control. As mentioned, you can do all standard modes. You can do NCAFM, dissipation, KPFM, Q control, bimodal. One of the benefits is that you can actually synchronize multiple devices to behave like they're one unit with multiple channels, called multi-device synchronization. And that allows you to do some of the more advanced measurements. We also have some newer lock-ins that are going to allow some new techniques. We have the gigahertz frequency lock-in amplifier, and essentially works from DC to 1.8 gigahertz. It has a very high sampling rate and a very fast response time, or time constant. It's essentially very similar to what we have in lower frequencies, but much faster. And then we have our super high frequency lock-in amplifier, which is the SHFLI. And that one uses super heterodyne frequency conversion, which allows us to go up into higher frequencies by up converting and then down converting. And it enables you to go up to about 8.5 gigahertz, but it goes all the way down to DC. So Today's invited speakers are going to focus on resonance engineering. Thank you, Hans Hug, for joining us, and Yoichi Mayahara. They're going to talk about their techniques later today. We are going to have a coffee break in between their two talks. And now I want to introduce Roman Stamp, also from Zurich Instruments. He's a senior application scientist and is an expert in SPM.